Hey guys, welcome back to the channel. I have a marine ECM test and possibly a repair. This is coming from Hawaii. Roger, this is your computer. This computer was here, I think it's almost a year or so ago from another customer. Now Roger is the new owner of the boat, and he has sent the computer, to see if it can be repaired. But like I normally do, I'm going to show you my connections and everything. I'm actually using a different lens this time where I will be able to get you closer. And I think the image quality of my simulator is already better. And I'm also will be able, because it's a zoom lens, so I can adjust it when I want to show you something closely where that is working. So you will see, because I did different connections. You can see a little spaghetti, but let me show you what I'm talking about. So I'm using now the MS12000 for the MEFIs and MEFI3s, and so all the marine computers. And I have created these type of connections where I have all the wires going to it. I have some harnesses that I have also made the connector. This is connected also to this, multi-tab connector in there. Then I can use it for all my tests. So this is Roger's computer. I'm going to flip it around just to read. He's been here since the 23rd October 2025. The computer number is 12584052. That's a MEFI4. The unique numbers is 842540097. And again, he's from Hawaii. This is very unique from Volvo Penta, this white sticker, and it says 5.0. This is a 5.0 liters. So I'm using the EST, let's call it ignition module, and I have a relay as a computer will command the fuel pump relay on in a relay box, and I'm using a test light instead of the fuel pump so we can see if that is the command or if it is being taken place, let's say. I'm going to move you over to his folder, which I have a few information to show you. Let me just see. Well, I connected this computer yesterday, and I had a full code for the EST. Well, actually, no full codes. Let me rephrase that. Let me make sure I'm in the correct folder. Yeah, Roger. The computer has 229.2 hours. The calibration, as I can show you here, that's the hours right there in blue. Let me make that a little bigger so you guys can see it from the distance. All right, so 229. On top of that, we have the calibration, which is 6629. That is the most important thing. But one thing that I noticed immediately, and this is why the computer was here, and I told this to the last owner, this computer reads the incorrect battery voltage. Is something wrong with the calibration or the circuit? They actually checked that out. I spoke to the last owner. He said he didn't want it to repair as long as it runs good. But now it's here. So let's see. I got idle values, but again, my connections weren't not there. As you can see here, I was using this type of ignition driver. Let me just get you closer where it says MEFI3, MEFI4. So that is actually for some of the EST drivers. Malibu uses this, not the Volvo Penta. And I have now, like you saw here, this is a completely different, ignition driver. So reading his notes right here, let me get that. It's a 5.0 Volvo Penta, but his concern is ECU voltage and fuel pump. I have also a piece of paper that he sent to. It says, Mike, my name is Roger. I bought George's boat. You had done a diagnostics on his ECU for the Volvo Penta 5.0 engine. In the video of YouTube, the ECU worked fine except for the low voltage. You said it was usable that way. I would like to have you fix the voltage on the ECU. It also seems that there might be a problem with the fuel pump connection. The fuel pump won't power up when the key is in the on position, or the key is on, and this fuel pump should come on as you turn the ignition on for like 2 seconds and then goes off, and it will not come on until you run the engine. The fuel pump power up when the key is on. I will also like to have you check that out and repair if needed. I have checked the fuel pump out remotely, and it does work. I have replaced the fuse box as well. I could not find the engine serial number. I looked where it was supposed to be, but couldn't find it. You might have it on your records from when Dan yours sent it to you before. I don't think I do. Let's see on that. Let me rush you here because I wasn't prepared to look for that. Let me make sure what I have on the last information because I don't remember having any of that in there. Yeah, no, he just sent the computer was the same thing, 5.0. So I don't have any of that information from the last visit or this visit. Let me go into this history of the last time. 1 second, guys. Sorry to take the time. Yeah, no engine serial numbers or anything. All right, so it looks like that's all I can show you from this visit. I forgot to show you the wire diagram. Very important too, right? All right, so this is the wire diagram that I have for these boats. The only thing that I'm covering in there with my position is the twin engine application. That is the CAN bus communication in between the two computers when you have a twin engine. But for the rest, everything is in here. We got, all the injectors for the B6 or the B8 because this computer will work for either one. If it's a 4.3 liters, it will be a B6, and the 5.0 and the 5.7s are B8 engines. So then that will be the injectors are connected on the same because even though it's a B6 or B8, this computer has only two drivers for injectors, and they're in J1 26 and J1 11. If we go over to the B8 engine, you can see that it also says J1 26 and J1 11. So the same drivers. It will just fire more injectors, but they're capable. So the connections are pretty much the same. I have another connections in here that I can show you is a little cleaner than that one. Let me get it right here. So this is the one, and I use this one most of the time because again, the drivers are the same. And you can take a quick pick if you want to save it for your folders. Sometimes the colors might not match your setup. It all depends on manufacturers, but the rest should be almost the same. We have the ignition driver right here. And like I said, the control comes from J231 over to the ignition control module, let's call that, which is inside the distributor. And that will command the coil, which it could be attached on the same bracket or separate. Again, it all depends on the manufacturer. As far as the fuel pump, let me just show you the fuel pump. SN driver is connected into J16. J16 will control the ground side of the relay. So right here, when I'm hovering the hand, let me make that portion bigger so we can get that into the diagram. So right here, we got a fuel pump. So if we see right here on terminal 30, we got a fuse. That means it's battery. And if it says 30, that means it's constant battery power. Otherwise, it will have 87 or another number. So 30 means it's constant battery power, and it has a fuse for protection. The 87 is power going to, in this case, the fuel pump module, the fuel pump. So this is the load side. So until the relay is command on, it will be no power going through this contactor inside the relay onto terminal 87 and then on its way for the fuel pump. It shows something else in here. It also powers up the injectors. So if we see here, that same power from the fuel pump relay will power up the injectors. So until that is on, it will not power up the injectors. So that is very important to see. But the control side, we have an ignition feed on terminal 86, and that's why it's 86 and it's not 30, because if we follow this will not have power until the ignition relay or MEFI system relay is commanded on. Let me just see, this is commanded on by the ignition switch. So we will have a constant power right here on this fuse, on this relay, terminal 30 directly to battery, 87 waiting to be controlled until it closes, and it has 85 directly connected to ground, and then 86 is coming from the ignition switch. So when you turn the ignition switch, this relay will close, and then the fuel pump will also have power to command the fuel pump, or to control the fuel pump. But it's also providing the terminal 86 on the fuel pump. The computer will control the ground side, and now we know that this is an ignition feed 86, so 85 it's got to be ground, right? Because this is the control side, so it's a winding, so it needs power and ground. So we already got the power, so the only thing that we're missing, and it's coming from 85, is the control side, which is the ground side from the computer. So I have everything connected as you see here, and instead of the fuel pump, which isn't connected to 87, I put that test light that I tell you. So we will see if that is actually working properly or not. All right, so just quickly trying to show you how it's connected in the boat and everything. So let me I have the picoscope and diacom ready to be connected. The computer is off right now. I'm going to turn the light here off so we can see a little better there. So let me put the ignition, and then ignition now. Well, the fuel pump is doing the prime. Let me do it one more time. We can see that in there. So I don't see the problem turning the fuel pump on with the ignition. Reading its note says the fuel pump won't power up when the key is on. So in this case, Roger, we could have a potential problem of either wiring integrity that needs to be checked, or a load that is preventing the power to go into the fuel pump properly. So what I would recommend you to do is use a multimeter onto the fuel pump power side, and see when you turn the ignition on, if you read any voltage. It has to be battery voltage, right? So if you see less than battery voltage, well, then fuel pump will not come on, because in here I only have a test light. And remember, this doesn't matter because this is the load side. So the only thing that this relay needs, and is happening properly, is power and the ground from the computer. And I have a real relay, as you see, they're connected. The load side, let's say if it's not enough voltage, you have even a bad relay or a bad wiring, right? Because the relay, the contactor side is completely separate than the control side. That is just a switch that gets pulled by the magnetic field that coil inside the relay does, but it's completely isolated and nothing to do one with another one, even though it's built into the same. But so if you have a voltage drop at the fuel pump power side, that means either you have a wiring issue, you have a bad relay. So I would make sure that when you're doing the same test, you can go into terminal 87 or at the fuel pump, and then you do the same test on the terminal 30 on the fuel pump relay, turn the ignition on, and see if that voltage drops when you're doing that, because then that means maybe the fuse is corroded or something back. So you can work from the relay backwards or forward. If you test in there and the voltage is at the fuel pump side, let's unplug the fuel pump and see if when you turn the ignition on, it's still low. If it's still low, okay, what else is connected to that? If we go back, let me take the picoscope and the diagram. If we go back to the wire diagram, what else is connected to the circuit? So we got the fuel pump, but we also have all the injectors. So we will have to check that wiring. You can remove fuse, the fuse is showing in here, hopefully is there. If you remove the fuse through the injectors and you redo the test, and now the voltage is proper, well, the problem is somewhere in the injector harnesses, or you got a shorted injector, right? Because if one injector is shorted, it will bring down that power so much that it will be not enough for the fuel pump to turn on. But in here, it's working properly. So I'm just trying to help Roger, because he's in Hawaii, and trying to diagnose his problem. Because as we see here, I'm going to turn the ignition back on one time. We can see that relay is working properly and is doing the prime. All right, so let me put the picoscope and the In the diagram, let me see what is this. In there, channel over voltage. What is over voltage? Maybe it's the green channel. Oh yes, because I'm connected to the coil. Yeah, I made that wrong. So just so you understand what I have in here on the oscilloscope, the blue channel and the red channel are the injectors, and the green is the coil activation. So that is what I have in there. So we will see the injectors firing and the coil firing. And I have that connected over to the coil side, not the control side, because we will check everything in there. If we have activation, it's because it's working, right? All right, so let's connect to the computer. Let me get another view here. Yeah, you can see that now. So this is Diacom Rinda, which it works perfectly for all these boats. I recommend that this tool to everyone that has a boat. This is Windows based. Don't buy the TechMate. That's a code reader. Yes, I can read bits, but no, this is a completely different tool. And here you can record all the pits. You can get a laptop with a cable. It comes with a long cable that you can connect in the engine harness. And you can set up the laptop recording as you even before starting the boat. Like right now, I can click on that record as soon as when I connect to the computer. I can start the recording and start the engine and take it for, let it warm up, take it to a short test drive, and then come back and then click. It can record up to 1 hour per session. So think about it, right? So how much information you can record in that, and you can then, because you can forget about the laptop, come back to the dock, stop the recording, turn the engine off, and then save the file. And now you can go and do an analysis of all the problems. If you're in a plane, you're doing the test and you start feeling something, you can stop the recording or have somebody with you stop the recording. And then now you know where, or take a time, like see where exactly is, take a picture of the screen to see how many where the position of the recording was, how many seconds were, because you can, or just stop it and then do another record and keep going, because you can stop, save, and keep going. But yeah, this is a very good tool. All right, here we're going to select the first one, MEFI 1 to 4, and this will fit all those from 1992 and up. Mer Cruiser, Volvo, Inmar, PCM, Marine Power, etc. All right, we're going to click OK. We have good communication. And now we're going to connect to the computer. All right, so fault codes, 0 fault codes. All right, that's not really being too helpful. And we saw that in that history that I saved yesterday, is 0 fault codes. The computer, I had it running because if we go on, let me open that. Let me go over to here. So yesterday when I connected the computer at first, the hours were 229.2. 229.2, and now we have 230.3. So I run this computer for almost 1 hour. I'm going to do a zoom glass. You see now we have 230.3. So that is already, like I said, an hour of running. And the only thing that I noticed, and let me run this computer. So we can see the fuel pump working perfectly every time. We have injection, both injector drivers, nice and clean. And we have the coil activation. So all that is working perfectly, Roger. The only thing that I did notice, and this is since the first time this computer was here, is look at the battery voltage on the computer pit. 10.3, 10.2 volts, 10.3 volts. So one thing that I wanted to show you, and this is where my new lens is going to be very helpful. And let me get the Pico out and the Diacom, 1 second. That is actually great because if you see the 10.3 volts, I am providing 13.3 volts. Come on, focus in here. A little slow focus, but no, you can see it fine. So it's 13 volts, so not 10.3. So that is definitely a problem in that circuit. Is either the circuit or the calibration. I don't know that yet because I haven't even opened the computer. Things you can see in here, I have 2 injectors. Actually showing 3. Let's see why. It's kind of weird. injector reading. Yeah, showing another injector. That's kind of odd. Let me take a look at that because I might be touching. I know what it is. 1 second, guys, because that is. I want to put these wires separated a little bit. Yep, that's what it is. I went and moved my wiring as I have to put heat shrink in the one behind them, and it's not going to affect anything. But you can see the wires showing 3 injectors firing. It's only 2, and hopefully you can read in there 2.93 milliseconds. Both are in there really good. And I also have in here now RPM. It's only showing 48, but I have it the RPM conversion right here. So 48 because this is the tachometer reading coming from the computer. So whatever hertz that shows me here, 47, 48 is converted to 688 RPMs. And I want to show you that that is very accurate. So I'm going to close that one and I'm going to put the RPMs. And you can see how the RPMs is reading now 689. So 688.4. So that is very accurate. So it is reading exactly what the computer is reading. So, but the hertz conversion from that tachometer signal is being read in here. So 47 hertz is exactly 689 RPMs. And this is something that I want to save to test because I have customers that have like a marina tell them that the RPM from the tachometer is 800 RPMs off. I'm like, well, I've never seen that, but it could be. I mean, I'm not saying it's not truth, but it's either something on the harness or it's something in the computer. So by me saving these files and gathering this data, I can use this to test other computers because that's very important. And I have saved that in my notes for all 8.1, 6.0, 5.7, 5.0, and 4.6. And I can use this for future tests. This is where gathering data is so important, right? So 47 hertz, 688. And I have a whole table where I can see how accurate the tachometer reading back is. And we can, I can put an oscilloscope. And this is the nice thing about having all now into one location. Let me go back to the correct view. The reason I like to use this is because now I have my oscilloscope in here. Let's say, I'm using the green channel for the coil. I can move the green channel from that coil over to, let's see what the ESC, the EST is in right here. No, not the ESC, the tachometer. That is the tachometer signal. So what is the tachometer signal looking at? Oh, I can see that in there, right? So it's looking nice and good as waveforms. And I can see that it's definitely reading fine because we got the 48 hertz. Otherwise, that would not be reading properly. So everything is looking good. So this is how I check these computers and how I use all the tools to gather information. I can always revisit the videos, and that's why I'm sharing that information with you. But I'm also testing it myself, right? So again, nothing wrong with this computer as far as the fuel pump, Roger. The only thing that I said and I can see here is the low voltage reading. So this is very important to understand. It's a reading. This is just a data pit the computer is using to say, okay, we got low voltage. I also always keep an eye right here. This computer running is around 750 to 800 milliamps. 800 milliamps. And that's including that relay and that test light that I am using in order to check the fuel pump activation. So nothing wrong with that. I'm going to put this back into what I'm using. Again, I can move the signals anywhere and put them as I please. But yeah, so this is definitely looking everything good. I don't have any problems with the fuel pump, Roger. So I'm going to open the computer up to see what I can do or what I can see as far as that battery voltage being the problem, because he wants to fix this up. And then, but the fuel pump, I don't see any issues. The fuel pump circuit is working as it's supposed to. So I'm going to turn the computer one more time. You're going to see that this light going off in a second, and it did. If I cycle the ignition, I just turn it off, and you can see the values on the oscilloscope going off. If I turn it back on, we can see that fuel pump prime happening every single time. So the only thing that we don't have, or I don't have connected into that same load, but again, that's nothing to do with the computer, will be the injectors. And I don't have your injectors, so I cannot put those in there. All right, guys, let me open this up and I'll be right back. All right, guys, I got the computer open and I'm going to do some tests. Yeah, so you can see, Roger, this is, again, your computer. A little hard to, yep, that's perfect in there. I have to change the other lens. I don't know what happened with the Tamron lens that I was trying to use, and there, out of the blue, is no longer focusing. And I try even my other camera. I'm using the Sony A1 II, and yeah, it's kind of weird because nothing wrong with the camera. I thought it was my Sony A1 first, but nope, it's actually the lens is not finding focus. Am I going to have to send it for test and a repair? About this long time ago, I haven't used it in a very long time. All right, so let's go into the test. So I'm going to put some readings on my screen so I can see. That's not the one. And close some pictures that I have open, and I get the ones that I need to have. Yep, power's in ground. So I'm going to check first. This computer has an ignition and a battery feed. The one is in J21. So you have the meter in there. You will be able to see it immediately. So that is there. And you can see 13 volts. Let me make sure I can see that too. And then the other one is in J219. Here's the ignition. 1 second, guys. My dog, he loves to bark. All right, so let's check the J219. Yeah, that will be ignition. And the ignition is on. So 17, 18, 19. And we can see 13 volts. So that is good there. So the pins are getting the correct voltage. Now let's go into the capacitors, the main capacitor. So this should be battery voltage too. And we got 1309. And then the other one, 13.13. So yeah, there is nothing wrong in there. I have also mapped out the computer internally. So I should be getting 12.4 volts in this other capacitor. Yeah, it's pretty close to that. We'll be getting 12.4 in this point right here that I'm checking. Yes, and it's 12.4. I know it's a little bright for you, but I need the light in order to see. So yeah, I don't see nothing wrong in there. Then we have a regulator on the other side of the board. This should be reading 12.4, close to 12.4 or so here. And we do have that. And then we should have 11.6 or so on this side. And that's exactly what we have. And then 8 volts, 8.1 in the center. And then we have that in there as well. This capacitor should read 8.1 or 8.2 in this case. And it's there. I'm just going around trying to see where we might be missing voltage, but it doesn't look like it. Let's take a look. In the microprocessor, I don't suspect to be anything, abnormal because we have good communication. So this should be 5 volts, and we do have perfect 5 volts, and then the other one should be 3.3. And we have the 5 volts and 3.3. So the voltage regulator is getting the correct voltage. It has got to be on the PID, the data PID, like I said. Let me read this order right here. So we should have 13 volts in here. And we do 12.3 on this side. And then we should have 12.3 on the other side as well. 12.39. Yeah, that's actually good. And this should be around 6.9 or so. 9 volts, sorry. I cannot read it. 8.9. So 9 volts, that's fine. And that all depends on how much was my voltage set into my power supply. So right now, that's why we have like cents, tenths of a volt or so difference, but nothing like, from 13 to 12 volts. So nothing in there is telling me otherwise. The computer looks pretty clean. I don't see any damage or corrosion or hot grounds. Nothing that has this stood up. So yeah, I'm going to have to look into this closely. But like I said, everything looks. Now you can see the board a little better. Yeah, sorry about that, but yeah, that lens stopped working, so I'm gonna have to send that one to get repaired or so, or test it out in another camera. But yeah, this one's is looking more and more as either a problem on the pad that the microprocessor uses to read the voltage, or we have a calibration issue. A little hard to know. So I gotta keep doing my tests. I'll be right back, guys. Hey guys, so I've been trying everything on this computer, and well, the computer is actually working good, but I cannot find a problem. It has to be definitely a path under the layers, and this board is pretty hard to find. And I have actually mapped out pretty much the entire computer, but it's hard to see, even though I can see the layers, because I can see where all the powers and grounds and everything goes. But the confirmation or where the computer is taking that measurement to know or to give you the pit for the voltage is unknown. I try everything to try to see if I match that voltage into all the points, and nothing. I even swapped the calibration, and I'm going to show you. Let me see. Yeah, the computer is on, so let me put the diagram in here. Let me get it into my screen. So let me show you the now. Well, the calibration is the same number, 6629. This is for these 5.0 Volvo GXIe. I think, right? But the calibration you will see on the first part is exactly the same, 6629. These hours, on the other hand, were 230.4 or 5 at the end, right? Remember where we were doing the test at the beginning. And this being a couple of hours for me, I can always revisit the video, but I'm pretty sure it was there. And as you can see right now, I have 208.6 hours. So this is another calibration with a little less hours that I, using on purpose. So I don't put anything that is going to be a huge amount of difference in hours, but I can see that indeed the calibration was installed. And but let's connect it, because actually it's not even connected. Let me reconnect to the computer. Yeah, you can see it in there. I'm selecting mode 1. And now let's reconnect. All right, so let me do the same thing. All right, so we had the 6629 calibration and 208.6 hours. But look at the voltage. It's exactly the same. So calibration change didn't do anything. So it's not about the logic. It's not about the maps inside the computer. It's, like I said, it has to be a path. And by the way, hopefully you're seeing that I was able to fix my lens. This is a Tamron lens that goes from 28 to 70. So it's a zoom lens. And the reason I like to use it is for what I did before, that I was able to get you close. Because the other lens that I use is this one. This is a very good lens. It's a G series Sony. It's original Sony. But this is it's just how you call this one? Let me just tell you. It's a FE 1.8 20G. So this is a wide lens for a landscape and so, which is good. In here you can see more of the office when I'm using this lens, but it's fixed onto 20 millimeters. That one, on the other hand, is 28. That's why I get a little closer now to the camera for you, but I can get that zoom in and out that I cannot do with this one. And not sure why I haven't used that lens before, because I had that lens for years and it's brand new. I mean, I have probably, I don't know, maybe take 20 photos with it. So, but yeah, let's go back into the test. So I'm going to put the Pico back in the screen, and I'm going to run it so we can see the computer running. I'm going to move the camera over to this view so you can see the fuel pump. I'm going to turn the ignition off. You can see that on the oscilloscope. And when I turn it on, the fuel pump relay is working good. So Roger, that portion I didn't do anything because there's absolutely nothing wrong with your computer. But let's make it run because I want to make sure that this is running the same way. We can see we have injector A and B completely nice and clean. And sorry, I'm looking at all the down, but I'm trying to see the image on that screen. So make sure there's everything looking good. And the other channel, the green channel, is on the coil activation, not even the EST, because I have, like I said, I have that ignition module. So that is the command to the coil, the same as in a regular coil in any vehicle. But we can see the light, the test light right there. Yeah, you can see it nice and bright for the fuel pump, and it's running good. I have, I'm going to move, or maybe get another reading so we can see the RPM. Let me put another reading in here. Forget which one I'm using. Oh, perfect. Okay, so that worked out. Let me just move those out of your way, or the way of the oscilloscope. So I'm going to put them into the upper section. And that looks a lot better for you. All right, so yeah, we can see the voltage does not change, and we have the RPMs, again, 688.4.5, so that's pretty accurate, my readings on my simulator here. I'm going to increase the RPM. I'm going to go around 4,000 RPMs. Yeah, 4,200. I'm going to raise the throttle position. I'm getting bombarded by a loan offer. I mean, they call me at least 47 times. So sorry if you call me and I don't answer. Please leave a message because I'm trying to get these people to stop calling me. All right, let me see the throttle. I got 18, so I want to go around 30. Perfect. And I want to go over to the map, which is right now in 11.4. I'm going to raise it around 19, 20 inches of mercury. Perfect. That is in 20. And I can see 5.8 milliseconds of injection. The computer is calling for 4.7. I can put a measurement onto the oscilloscope and we can read, or we will be able to read what is exactly happening on real time, which I know my simulator is pretty accurate. But let me just show you low side. Okay. And now we got that reading in there at the bottom. You can see 5.7. That's exactly what I got. 5.78, because it's 5.75 sometimes. There's nothing wrong with that. So everything is looking good in your computer, Roger. Like I said, I'm sorry, but I'm not able to help you with this. I tried my best. I did everything I could. And it's like I said, it's an unknown feedback. It has to be a resistor or a capacitor that is a little shorted, let's say, and it's draining too quickly that voltage, because usually the computer's microprocessor, it has protections, right? So that voltage is going through resistors just to make sure that it's just going to be a signal, not an actual voltage being used. And that's how the computer will read it. But what is or where it is I have not been able to find it. And I have spent hours on this, so I try my best, but sometimes it's things you cannot correct because it's the nature. I mean, there's no schematics, no data sheets, or anything. So all the information I have from this computer, I have made myself. But yeah, for the rest, the computer is running good. All right, let me go back to, you see, I got a message from the loan department. That call that I just didn't take, it was a loan offer. And I made a mistake. If you ever get a call from a loan, like and I know a message, don't answer it. And when they're leaving a message, press 9 to stop this from happening. If you don't want a loan, I made the mistake, and I press that. As soon as they see that they know that you are a real person, they keep calling you and calling you and calling you a message. And I have blocked probably 700 numbers. But they keep changing the number. They keep changing the names. I mean, it's like Michael, Alexis, just name it. And there's it's just the same. And it's fake. I'm so tired of that. I'm trying to, right now, because the federal is shut down, I've been trying to put my phone number in no call list for those kind of situations. But it's just, I cannot do it because of the shutdown of the government. Let me go over to 600 and I don't like 666. All right, let me bring the throttle to around 7 to 10%. 9, that's fine. And then bring the map to 12.6, which is what I usually use, or what I normally use at idle values. All right, that's around there. But yeah, we can see that wrong voltage reading on the computer, but Roger, this is not affecting anything. All the voltage rails and everything in the computer is perfect. So that's why the computer is running good. And you can see clean injector drivers, the ESC signal is perfect, so nothing wrong. I can also show you here, if I move you to this view, this auto lights that you see here is the IEC. I have connected everything. So this simulator has simulation signals for the IEC driver, for the fuel pump relay, and etc. In this case, I'm using that just because I have a customer telling me that a computer that I tested, I don't know, maybe 2 years ago, it was a glitch on the fuel pump relay. And at that time, I was using the simulator, but I have not found a difference, me using that or this, that it has led me to believe that it was a glitch on the fuel pump relay that I couldn't catch. I'm like, if I cannot reproduce it in here, there's nothing I can do. And I'm sorry, but there is things that I cannot reproduce, which is your harness, the corrosion on the harness, and things like, yeah, you might say, well, Mike, we put a new computer and it corrected it. Yeah, I corrected it now. Now because you put a brand new computer. Wait a couple of months. Use that computer and let that corrosion in the harness and everything. That I have a customer that have replaced the computer 4 times. 4 times. And you think that the company is going, oh, yeah, we send you another computer for free. No. Another $4,000. Another $4,000. You know why? Because, yes, you put the computer, and he says, Mike, we put the computer and it runs good for 2 to 4 months, and then all of a sudden it dies again. Can you tell me what it is? I'm like, you cannot find it in the boat with everything connected, and you want me to tell you what it is? It's not the computer that is getting bad because of the computer. It's because it's something in the boat that is damaging every single computer. And I tell them what you should do is replace the harness, because it's very common. I mean, boats are exposed to water, to corrosion. The hardness of like weather conditions. I mean, if you go into winter and it's a little bit of water or a little cut in the harness and the water got into, what it's going to do is freeze and going to expand, right? And then the weather changes and it diminish the size. But now that wire got expand, and all the water now enters everywhere. And that's how the corrosion gets in there. It's just a little tiny cut, and it's a problem. I have seen technicians that open harness to do tests, like back probing, what we call back probing or piercing. And you should seal that with like electrical liquid tape. It's specifically for that. Use heat shrink. Do something that will prevent the water from entering. Otherwise, it's how harnesses in later years, they just become garbage. But yeah, it is. That's what I tell the customer. Yeah, am I corrected now? But the problem is not the computer. The problem is it's still on the boat, and your computer is probably more prone to reproduce it because it has been taking the hit for a long time. I cannot reproduce in here. The problem, why? Because I cannot find, or I cannot put that extra load of the corrosion that you have in your boat. All right, guys, but yeah, I'm just trying to talk and see if there's anything wrong with this one or bad. But no, it's actually working really well. So, Roger, that's all I can do. Your computer is actually good. There's nothing I can do about that voltage change or reading. But for the rest, it's a good computer. We have seen all this time that fuel pump relay working and the fuel pump every single time. I'm going to turn the computer once again. You can see the battery voltage goes to 0. Ignition back on, and it comes immediately on. And when it runs, it's right there. So is anything wrong with that fuel pump circuit? Not at all. Not the computer. Everything in the computer is It's perfect. All right, guys. That's it. Another test. I hope that you at least get to learn a little more of my techniques and the tests that I do here. Voltage drop test is all I did in here. Try to find the difference, and that's what you can do in the boat. All right, guys, I'll see you next time. And please don't forget to subscribe. That really helped my small business a lot. Thank you so much. See you next time. Bye-bye.